Here we are at 2.7, the last lesson for Chapter 2. It probably felt like we were never going to get here. Today we're talking about solving real-life problems. So our learning goal for this, in this lesson, I will solve real-life problems involving linear equations. So we could use linear equations to model any situation where we have a constant rate of change, because remember, a constant rate of change would be our constant slope, and if we have a constant slope, that gives us a linear equation. So I've already written out our first example to save a little bit of time. So for example 1, we have the percent y in decimal form. So what that means is like 75%, y would be 0.75. So the percent y of battery power remaining x hours after you turn your Game Boy on is y equals negative 0.3x plus 1. So this is the equation that we're going to use. X is representing our time, how many hours have gone by since you've turned on your Game Boy. Y, this y right here, is representing how much battery power you have left given that you've had it on for this many hours. So our first step here says to graph the equation. So when I graph this, I want to just keep in mind what I'm doing. We're talking about a situation where we're only going to have positive y values because we can't have a negative percent. We can't have negative 10% left of our battery. And we're also talking about a situation where we can't have negative time. We can't say, I turned my Game Boy on negative 3 hours. That doesn't make any sense at all. So, oops. I only really need my first quadrant here. Let's see. 6, 7, 8, 9, 10. I want to make sure I can fit my y-intercept on there. So if we're talking about percent, I really only need my y-axis to go up to 1, which would represent 100%. And you can see that that's what my y-intercept is. So I'm going to count by tenths. 4, 5, 6, 7, 8, 9. And this 1.0 represents 100%. So let's label our graph as battery power remaining. And then down here we have 1 hour, 2 hours, 3 hours, 4 hours, and that'll go on. And this is time in hours. It's always good to label your graph. And then what I'm going to do is I'm going to graph this equation. So my y-intercept is 1. So that should make sense. I haven't turned my Game Boy on. It's been charging. I have 100% power. Now I unplug it. I turn it on. My slope is negative 3/10. So that means for every hour, this is like negative 0.3 over 1. For every 1 hour that goes by, I lose 3/10 of battery power, or 30% of my battery power. So I go down 3/10 over 1, down 3/10 over 1. So that's where using tenths to count up is kind of useful here. It made it a little easier to graph that slope. Now I'm going to connect all these dots, all these points. And there's really no reason to keep drawing my line down into the negatives because, again, we can't have negative battery power. So this is really the only part of my line that I care about. So here I've graphed the equation. Part B says interpret the intercepts. So I want to interpret what this point up here means and what this point right here means. So this one we've already talked about a little bit. This is when no time has gone by. I'm starting at 100%. So the y-intercept, which is 0, 1, means we're starting with 100% battery power. So in order to know that, I had to know what Y represented. Remember, Y represents the percent of battery power remaining. And then my x-intercept, which is down here, I can't quite tell what that is. It looks like it's in between 3 and 4, maybe 3.5. But what that represents, we'll figure out what that point is in a second. But what it represents is, if you look, that point is where I have 0 battery power left. So that x-intercept means you run out of battery after, we don't know how many hours yet, after blank hours. So my x-intercept is when I don't have any battery left. So let's figure out what that point is real quick. What I would do is my equation, negative 0.3x plus 1. Remember, this happens when my y equals 0. That's my x-intercept. So I can even put that in there. 0 equals negative 0.3x plus 1. To solve for x, I subtract 1 from each side. So negative 1 equals negative 0.3x. Divide each side by negative 0.3. Oops, I forgot my 0. And I will get that x equals, basically this works out to be 3 1/3 or 10/3. But 10/3 hours, oops, I'm sorry, you can't see any of that. 10/3 hours doesn't make any sense. I would need to leave it as 3 1/3. So we run out of battery after 3 1/3 hours. My intercept is 3 1/3. So that was the second part of that problem. It was interpreting the intercepts. And then part C says, after how many hours is the battery at 40%? So I could use my graph and go up to 40%, and it looks like that's right on at 2 hours. So at 2 hours of use, I have 40% of my battery left. But if I wasn't quite confident in my graph, I could also plug this into my equation. And I could say, okay, battery at 40%, that's my y. And I want to know how many hours that would be my x. So my y is 0.4, because that's 40% remaining. That's going to equal negative 0.3x plus 1, and I'm solving for that x. So I subtract 1 from each side. 0.4 minus 1 is negative 0.6. I divide each side by negative 0.3, or negative 3/10. And because these are both tenths, look, they're both negative. Negative divided by negative is positive. And they're both tenths. So I can think about it as 6/3, or 6 divided by 3. And I get 2 equals x, which is what we looked at on the graph. So after 2 hours, the battery is at 40%. So I just had to know which of these went in for my y and which of these was I solving for, which one went in for x. So it's not too tricky, it's just using all the information that we've done in this chapter so far and kind of putting it all together in a real life situation. Our second example gives us a graph instead of an equation and asks us to figure out what's going on in this situation based on the graph. So this graph shows the cost y in dollars of a BMX track membership and entry fees for X races at the track. So y represents how much you have to pay, how much you have to pay for a membership and races. So if you want to do 2 races, you have to pay more than if you're doing 1 race, that kind of thing. So our first part of the problem says find and interpret the slope and y-intercept. So I'm going to do this the same way that I have found slope. Let's zoom out a little bit so we can see everything at once. The same way we found slope before, which was basically taking 2 points and using our slope-intercept form, using our slope equation, which is y2 minus y1 over x2 minus x1. So I see that 2 races is $80, so let's use the point 280, and let's use our intercept, which is 0.60. Let's plug those into this equation, so we get 80 minus 60 over 2 minus 0 is 20 over 2, or 10. If we think about our units on this, this is $20 for 2 races, or another way, once it's simplified, is $10 for every 1 race. If you think about what those units actually mean, our y's represented cost, x represented the number of races, cost per race. So our slope means you're paying $10 per race. We also, so that's our slope. We also needed to find the y-intercept, which you can tell by looking at the graph. I hit the y-axis at 60. I even used that to find my slope, 0.60. So if you remember, 0 is in the x, which represents how many races you do. 60 represents the cost. So 0 races cost $60. You might be wondering, why on earth would you pay if you're not racing? But remember, this is the membership and the entry fees for the races. So what this is telling you is that just the membership is going to cost $60. If you don't race at all, you still have to pay a $60 upfront fee. So that's what this intercept tells us. So then for part B, we need to write the equation of the line. Well, we have our intercept. We have our slope. Let's just use y equals mx plus b, where we can write our slope as 10 and our intercept is 60. Y equals 10x plus 60. And then the final question asks, how much does it cost to be a member and enter 4 races? I can do this 2 ways. I can do it by looking at my graph. 4 races will cost $100. But then to check and make sure that works out, let's put it into my equation that I came up with in C. So 4 races are represented by x. We want to know how much it's going to cost. So we don't know how much it costs, but I know that I'm doing 4 races, and I have that $60 that I have to add on for the membership fee. So y equals 40 plus 60, or y is going to equal $100. So those questions were pretty easy to answer, just based on looking at that graph and coming up with the equation. So you should be comfortable doing both. You should be comfortable interpreting a situation where you're given a graph. You should also be comfortable with the one we did, like with battery power, where you're given an equation and you have to figure things out based on that equation. So those are the things that are going to be asked of you.